Hello, everybody. It's Mr. Moore again. This time we are talking about eighth grade real numbers unit. In the real numbers unit, we have to deal with something for the first time that we didn't necessarily have to deal with in seventh grade math, and that is going to be square roots. Okay, one additional thing that we do have to deal with square roots is actually multiplying a radical or a number that would result from what's under a radical sign times something that's on the outside. So that it didn't come as a surprise if it shows up on STAR or shows up on a test, we want to make sure that you are aware of how to simplify it. Now, technically speaking, this is going to be something that will be retaught in algebra, but I wanted to ensure that you guys were aware how to do it just in case, again, it pops up sooner than later. And so here goes nothing. So first of all, everybody, let's go ahead and review. We know what a term is, okay, or we should when we're dealing with the algebra unit. That'll be covered again there. But a term is going to be part of an expression. An inequality or an equation, of course, is going to have an inequality symbol or an equal sign, but an expression will not have either. But there are times that we still have to simplify expressions. So just so we're all aware, what I want to do is I want to highlight what is a term in what we're about to do. So, for instance, what I've highlighted in red or put parentheses around, those are going to be two parts or two terms that are going to be listed for this expression. We have the 2 that's on the outside of the radical sign, and we have the radical sign, and underneath the radical sign we have a 9. Okay, we would be able to take the square root of 9. Just as a recap, everybody, this is a principle that has to do with the distributive property. Anything that is on the outside of a set of parentheses, and of course there were no parentheses there, but it's assumed that they could be there. So basically whatever is on the outside could be multiplied by what's on the inside, okay? So for instance, if I know that there is a 2 being multiplied by whatever the result of the square root of 9 is, it's like saying, and I'm going to change the color for us, it's like saying 2 times 3, okay? Again, the square root of 9 is going to be 3. What's on the outside of the radical sign is 2, but we know that based on distributive property, I multiply what's on the outside of a term times what's on the inside of another term. In this case, again, we have drawn imaginary parentheses around both of those terms. We assume that they are there, but they clearly are not there. But we know that when things are right next to each other, for lack of a better way to say it, those things are going to be multiplied together. So what would the simplified expression look like? Again, 2 times the square root of 9. 2 times the square root of 9, we know the square root of 9, what number times itself is going to give us the number that's under that radical sign? It's 3. So 2 times 3 is going to result in 6. Okay, so that's how you do that. Let's move on to another simple one, and then we'll move on to one that's a little bit more complex. So we have 4 times the square root of 36. It's going to be the same concept, everybody. We know that this is a term and this is a term, okay? 4 should be multiplied by whatever the square root of 36 is. I know that 4 multiplied by 6 because the square root of 36 is going to be 6. 4 times 6 will give me 24, okay? So what I'm going to do is I'm going to erase this line, everybody, and make this, give ourselves just a wee bit more space. Let's do that, okay. Give ourselves just a little bit more space. And let me change that to black as I wanted to. All right, so we're going to give ourselves just a little bit more space. So again, just like in the previous examples, everybody, I don't want you to get scared because now we don't have perfect squares anymore. We do have an approximation that we're going to have to make with the square root of 17. So the first thing that I want to do, again, is identify what my terms are. So if I identify what my terms are, they are 2 times the square root of 17. changing my color. Again, nothing's going to change for what's on the outside of the radical sign. But what is the best approximation for the square root of 17? So what I would do is I would pull up my calculator here. This calculator looks a little bit different because it's the one on the computer than the one that you would have. This symbol right here, where you have the x under the radical sign and this 2 on the outside, that just means the square root. You'll learn different numbers coming up in algebra. At any rate, I would do the square root of 17, and the syntax was off there. We're going to try that again. Okay. So the square root of 17 is going to be approximately 4.12. So what I want to do is I'm going to go back here. I'm going to change this to 4.12. So the square root of 17 is approximately 4.12. I know that the number that was on the outside of the radical sign, which is going to be multiplied by that, is going to be 2. So again, if I pull up my calculator one more time, I want to clear everything out because the longer version might give us a slightly different number than we should. So, or it will anyway, times 2 is going to give me approximately 8.24. And if I was asked to round this to the nearest tenth, of course it's going to be 8.2 because this number right here tells me that I would round this to 8.2. Okay, or if I wanted to round to the nearest whole number, it's going to be approximately 8. But more than likely, they're going to ask you to round to the nearest tenth, or they may just ask you to keep the number as is. So we don't know. So just in case they did ask you to keep the number as is, my approximation would be 8.24. So if they ask in the question, say, which is going to be the closest value to the square root of 17 multiplied by 2, if you were given, say, the answer choice 7, 8, 9, of course, it is closest to the whole number 8. Okay, that's our quick lesson, everybody, in multiplying radicals. I hope that this has been beneficial, and I'll see you soon.